Do you like to know if your online ordered drug is an original or fake? Do you like to know whether your expensive wine really comes from a noble vineyard, or if a cheap wine was filled into a bottle with counterfeit labels? Do you like to know if sensitive goods were handled with care during transportation? Sometimes it would be valuable to know more about a product. Printed electronic devices developed in the EIT KIC raw material project SuperSmart could help to find the answers. The SuperSmart sensor technology enables affordable and sustainable paper-based printed tags, let's say for shock detection or counterfeiting. Why paper-based printed sensors? Because it's super smart and beautiful. All joking aside, to reach a commercial success with printed electronic devices, you have to answer two questions. How to produce smart labels in a cost-efficient way, and how to design these products to make them sustainable and to reduce negative environmental impact. To begin with the substrate. Paper is an old material with a bright future. It's easy to recycle, hard-wearing, simple to print on, cheap, and the primary raw material is renewable. In the SuperSmart project, a paper was developed that is suitable for electronic devices and print processing. The paper has an extremely smooth surface and reduced soaking effects. With the SuperSmart processes, it is possible to print low-cost silver inks with high quality and conductivity on this paper, resulting in a paper-printed circuit board. Now the next steps. Cost drivers in the production of smart labels are the functional materials and the process techniques. Affordable as well as printable smart sensor materials are required, not on a high-cost labor scale, but in sufficient quantities. The upscaling of material and particle synthesis, a sophisticated compounding and a robust printing process were developed by the SuperSmart project partners. For the demonstrators, the upscaled SuperSmart materials were processed at high throughput production schemes. Building up an anti-counterfeit tag, antenna structures were printed on the pre-manufactured paper that combine an optical sign based on electrochromic layers with a communication microchip and a battery. This anti-counterfeit tag can be processed roll-to-roll with high yields. The conventional silicon component and the battery are integrated by a hybrid approach using automated pick-and-place technologies. Also for the piezoelectric shock detection sensor, the printing is done roll-to-roll on a modular printing device. In order to be able to print the different layers without lateral deviations, an automatic alignment system was developed, ensuring that layer after layer is printed exactly on top of each other. Because the sensors have to be polled, the SuperSmart team has built an automated polling station to poll a multitude of sensors, sheet to sheet or roll to roll as well. Again, silicon chips for communication and batteries are integrated by pick-and-place technologies. The SuperSmart team had also sustainability in mind. The devices were put into the standard paper recycling process. It was investigated at which step the functional materials can be separated from the paper parts. A life cycle analysis compares the relevant parameters for plastic and paper-based printed sensors as well as for conventional sensors. SuperSmart naturally comes out on top. In consequence, SuperSmart demonstrators can be produced in a cost-efficient way with upscaled functional materials on a high throughput processes and with a limited environmental impact. The decisive factor here is a change from a plastic-based electronic device to an electronic device made of paper. Using the anti-counterfeit tag, you can communicate via an NFC device using a smartphone app. If the smart label contains the optical function and the identification keys are identical, the electrochromic signage changes the color. This is easy to see and allows a fast verification of the originality of the product. The shock detection tag allows the recording of shock events during transportation or even the product lifetime. Additionally, it can be monitored if the tag experienced large impacts. These tags can be produced for a low one-digit eurocent amount. SuperSmart demonstrators prove that printed electronic devices might play an essential role in building a smart environment, revealing the real competitiveness of the products as well as tackling the recycling aspects in detail. It's time to make a change. For the nature, for us, for you. That's why we apply for the competition.